Hello again. This is HESI Chemistry Review videos. This is video number 4 in the Elements and Atoms section, and we're going to talk about the charge or oxidation number on an atom. And so quick review, here we have our protons, positive charge, neutrons, neutral, and electrons, negative charge. To review some of the things from the first 3 videos, the atomic number is equal to the number of protons. So in this case we have 3 protons, so our atomic number is 3, and that also tells us the identity of the atom. And so for that we would look at the periodic table. The atomic number is always a whole number, and they go sequentially across the periodic table. So atomic number 3 is lithium, so that tells us that this is a model of the element lithium. The atomic mass is the protons plus the neutrons, so you just count them up, 1, 2, 3, 4, 5, 6. So in this case, this is a lithium atom with the atomic mass of 6. And remember to ignore the electrons when you're asked to find atomic mass. So now we're going to move on to the charge, and the charge is sometimes also called the oxidation number. They're the same thing, and it's a positive or negative number or 0 if it's neutral. So to get that mathematically, it's protons minus electrons. So to do this one real quick, 3 protons minus 3 electrons means a charge of 0, which means neutral. So the example we have here is where we have 5 protons. So let's put 5 protons in our nucleus. 6 electrons. So we've got 3 so far, and electrons have a certain way of arranging themselves, but that isn't super important in terms of the HESI. So when you see me putting them certain places, that is the right place for it, but don't stress if you don't get why I'm putting them where I am. Okay, so 6 electrons, 1, 2, 3, 4, 5, 6. Okay, and notice that in this case we're not told how many neutrons we have, and that's because neutrons don't impact the charge in any way because they're neutral. The neutrons themselves don't have a charge, so they don't change the charge of the overall atom. So even though this atom would have some number of neutrons, because it's not mentioned in the problem, I'm taking them out just to avoid confusion. We'll keep them in later. So question is, what is the charge? So 1, 2, 3, 4, 5 protons minus 6 electrons. 5 minus 6 gives us -1, and that's the overall charge. There's another way that you can look at it, is that each proton is neutralized by an electron. So if you pair them all up, you'll either end up with everything paired and it means it's neutral, or with some extra protons or some extra electrons, and that will also tell you the charge. So we can toss out every pair. We'll just line them up over here. So that proton has a match. This proton, what did I just do there? Okay, has a match. This proton has a match. And I'm not matching them with any particular electron. It doesn't matter. We just want to know how many altogether have a match. And then when we match them all up, do we have any left? So once we've paired them all up, so these all neutralize each other, so the net charge there is 0, but we still have 1 remaining electron. So that's another way to get to the overall charge of -1 if you want something that's a little more visual and less math. Another way you could be given a problem like this is they tell you the charge and they tell you either how many protons or how many electrons, and you have to calculate the other one. So in this case, we're trying to get to how many electrons. So I'm going to start out by taking all the electrons out, putting these 7 protons in, five, 6, 7. Okay. And we want an overall charge of +2. So I'm going to keep these in the nucleus, but I'm going to set them aside. These are the 2 protons. And again, it doesn't matter which protons they are. They're all equivalent to each other. But we want to remember that these 2 can't have a matching electron. So we want matching electrons for the rest of them, which is 1, 2, 3, 4, 5. So that means we have to have 5 electrons. So basically at that point you have your answer, which is 5 electrons, but I'm going to go ahead and, they go in here, I'm going to go ahead and put them onto the atom. 1, 2, 3, 4, 5 electrons. And so that means that these 5 protons get neutralized by these 5 electrons. And then there are 2 protons left over that give it an overall +2 charge. So mathematically what we're doing here is we're plugging in the numbers we know into charge equals protons minus electrons. And so +2, which is just a positive number 2, equals 7 for the protons minus the unknown number of electrons. And then we have to solve for E, so add E to both sides gives us E plus 2 equals 7. And then subtract 2 from both sides gives us 5 electrons. If you're not following the algebra here, then you definitely need to review some real basic algebra for the math section of the HESI, and I highly recommend Math Dude on YouTube for that. But hopefully you're good with that level of algebra. Okay, so also it can be larger numbers where you're going to be, you could still draw it out if you're more comfortable doing that. But when the numbers are larger, it's just easier to use the equation. So anytime the charge is neutral, then you know you have the same number of electrons and protons. But then they could twist the question a little bit by, instead of saying how many protons are there, they could say what is the atomic number. So that's why you need to always remember atomic number equals number of protons. And then if you were to plug it into the equation, you would say 0 equals protons minus electrons, which is 29. And then add 29 to each side gives you 29 protons, which is the same as saying that the atomic number is 29. Okay, so you remember when we were doing the mass, we had to ignore the electrons, and that's because the electrons are teeny tiny and essentially have no mass. Well, the neutrons have no charge. So anytime you're asked about the charge or the oxidation number, if they tell you how many neutrons you have, do not use that number anywhere because it doesn't matter, because neutrons do not change the charge because they're neutral. So if you have 5 protons, 6 neutrons, 5 electrons, and they ask for the oxidation number, cross out the neutrons, and then you see, oh, I've got 5 protons and 5 electrons. Everything cancels, and it's neutral, or 0 charge or oxidation number is 0. Those are all different ways of saying the same thing. And then again, if you have a charge, they tell you the charge, they tell you how many protons and how many neutrons, and they ask for how many electrons. Then again, you can pair everything up. So I've already got 7 protons here. I can add the 8 neutrons into my model, but ultimately I'm just using time to do that, and it doesn't really get me anywhere because the neutrons don't matter. So if you're going to do this and you're going to draw it out, in reality it makes more sense to just not put the neutrons in there. 1, 2, 3, 4, 5, 6, 7, 8. I'm just doing that so you can see how it looks with the neutrons in there. And then now my charge is -1, which means every proton has an electron and then 1 extra electron. But so to do this, I'm gonna first make it neutral. 1, 2, 3, 4, 5, 6, 7, and I have 1, 2, 3, 4, 5 electrons. So there's 1, 2, 3, 4, 5, 6, 7 electrons. So now every proton has an electron and it's neutral, but I need an overall charge of -1. So I need to add 1 more electron to get that charge of -1, and that gives me a total of 1, 2, 3, 4, 5, 6, 7, 8 electrons. Or mathematically, plug in the charge. -1 is equal to 7 minus the electrons. And then if I solve for the electrons, that also gives me 8. So that's it for the charge. Next time we're going to pick up with isotopes.